Good morning, students. We want to have a quick lesson on the kinetic theory explanation of Charles's law. In our previous lesson, we had stated one of the gases' law, which is Charles's law. So now we want to use this medium to explain the kinetic theory explanation of the gas law known as Charles's law. Now, we are going to have to demonstrate so many things this morning. Now, the explanation goes this way. When a gas is heated up, okay, so should you have a gas, say you have a gas, and that gas is heated up. When a gas is heated up, what happens is that the molecules of the gas begins to move rapidly, and this leads them to have an increased kinetic energy. All right, so the heat is affecting the gas and is causing the molecules of the gas to gain kinetic energy. So the kinetic energy of the gas increases. Now, when this happens, the number of collisions made on the walls per second increases. The number of collisions made on the walls per second increases, and this results in an increase in pressure. Okay, so when the kinetic energy increases, it causes an increase in pressure. All right, now the increase in kinetic energy of the molecules increases the number of collisions, and when the number of collisions per second made to the walls of the containing vessel increases, then the pressure of that gas increases. All right, but we understand that according to Charles's law, the law states emphatically that the pressure should remain constant. Okay, so according to the law says that pressure should remain constant. But in this case, the heat applied to the gas has increased the kinetic energy of the molecules of the gas, increasing the number of collisions made to the walls of the containing vessel, and thereby has also increased the pressure. When in fact, according to Charles's law, the pressure should be kept constant. So, to now correct this pressure so that it doesn't increase but remains constant, all you need to do is that you have to increase the volume of the gas. So, when the volume of the gas is increased, the pressure remains constant. So the pressure can come back to its normal only when the volume of the same gas at this point is increased. So on the vice versa, what it means is when the heat, okay, so when heat is taken away from the gas, that gas will begin to cool down. Are you getting it? Now, on the other hand, when the gas is undergoing a cooling process, okay, when the gas is cooling, what happens now is the opposite of when it is heating up. So when the gas molecules are cooling down, the what we say is that the kinetic energy of the molecules also reduces or decreases in this case. Okay, so if the gas is cooling, then it will mean the kinetic energy is also decreasing. And in this term, when the kinetic energy of the gas molecules reduces or decreases, it means that the number of collisions against the walls of the containing vessel per second has also decreased. And when this happens, the pressure of the same gas also decreases. Okay? So when you're going under cooling process of the Charles's law explanation, when the gas is cooled or when the gas is undergoing cooling, its kinetic energy decreases. When the kinetic energy decreases, what it means is the pressure of the gas also decreases. All right, but we understand again that according to Charles's law, the pressure must remain constant. All right. So to bring the pressure to a constant, so the pressure must remain constant. So to bring the pressure back to a constant state, what you need to do is to decrease the volume of the gas. So when you decrease the volume of the gas, you bring the pressure back to its constant state. This is basically all the explanation to the kinetic theory explanation to the Charles's law. Okay, so in this case, when the gas is heating up, the kinetic energy increases. Okay, the kinetic energy of the molecules of the gas will increase. When that happens, the number of effective collisions per second made to the walls of the containing vessel will increase. All right, and thereby increasing the pressure. So to correct the pressure's increment, you need to increase the volume of the gas just to bring the correction to the pressure to keep it in a constancy or in a constant state. Again, if the gas is undergoing a cooling process, the kinetic energy of the gas molecules reduces or decreases. And when this happens, the pressure of the gas decreases. When the pressure of the gas decreases, then it will mean that we have not obeyed Charles's law. And in order to correct Charles's law and to keep the pressure constant, we need to reduce the volume of the gas. In this case, when the volume of the gas reduces or decreases, then the pressure can be kept at a constant state. Okay, now let us quickly look at the pressure law. All right, now the pressure law is one of the gas laws, actually the third that I mentioned earlier in our previous video lessons. Okay, now with the pressure law, it says that the pressure of a fixed mass of a gas at constant volume is directly proportional to the absolute temperature of that gas. I'm repeating it again. It states, the pressure law states that the pressure of a fixed mass of a gas at constant volume is directly proportional to the absolute temperature of the gas. So what this law simply is stating is that the pressure of the gas is directly proportional to the temperature. And this occurs only at constant volume. Yes, so when the volume is constant, then the pressure can be directly proportional to the absolute temperature. Note that P is indicating our pressure and our T is indicating our absolute temperature. So, in accordance to our our pressure law, with the expression we have now, we can change that into an equation. Now, we just introduce a constant, KT, and this constant is what is needful to us. So the constant now becomes pressure divided by time. All right, so it means that the pressure divided by time is equal to the constant, and this is basically what we refer to as the pressure law. Okay, so according to the pressure law, for instance, we could say that P1 all over T1 is equal to P2 all over T2. Note that the T are all temperatures, but absolute temperatures. It's very necessary you know what absolute temperatures are. Those temperatures measured in the Kelvin. Okay, so for instance, we could say that P1 and P2 are pressures at the two states, and T1 and T2 are the absolute temperatures at the two states. Okay, so P1 is the pressure at temperature T1, and P2 is the pressure at absolute temperature T2. Okay, so now let's move on and look at the kinetic theory explanation of the pressure law. So now we're looking at the kinetic theory explanation of the pressure law. All right. So just as we explained that for Charles's law, we're going to explain that for the pressure law. Now, with the pressure law, we realized that the volume was kept constant, okay? And then the pressure was directly proportional to the absolute temperature. So what it means simply is that when the temperature of a confined gas is increased, all right, so you may have a gas which is confined, okay? Now, that means that it is introduced to heat. And when it's introduced to heat, its temperature, okay, its temperature of the molecules will increase. So simply when the temperature of that confined gas is increased, what happens is the kinetic energy of the molecules of the gas, as well as the speed of the molecules of the gas, will also increase. So when the temperature is increased, the kinetic energy of the molecules of the gas will also increase. So, so it will increase like that. And when it also increases, it means that its speed, the speed of the molecules of the gas, will also increase. All right. So the temperature increases. So the temperature of the gas increases. What happens is that the kinetic energy and the speed of the same gas molecules will also increase. Are we here? Now, when this happens, since the volume is constant, the number of collisions that are made per second on the walls of the containing vessel also increases. And this results in an increase in pressure. So since kinetic energy is increased, the speed is increased, then the number of collisions made to the walls of the containing vessel was also increased. And when that happens, it means that the pressure of the gas will also increase. Now note that this should occur at a constant volume. But in this case, we are going to see what is happening. Now, when the gas is cooled, the kinetic energy decreases. All right. So when this same gas is cooled, when this same gas is cooled, means that when the heat is taken away and the gas is now cooled. All right. So when the heat is taken away and now the gas is cooled, what happens is that the kinetic energy will decrease, the temperature will decrease, the speed will decrease. And when all these decrease, okay, since the volume is constant, the rate of bombardment on the walls of the containing vessels will also decrease. And this will result in a decrease in the pressure of the gas. All right, so when this is cooled, what happens is that the temperature is going to decrease. Then the kinetic energy will also decrease. And when that happens, the speed will also decrease. And when all these are decreased, then the number of effective collisions against the walls of the containing vessel will also decrease. And when that happens, the pressure will also decrease. So when all this is said and done, finally the pressure will decrease. And this is basically the explanation or kinetic theory explanation of the pressure law. Thank you so much for your time. I believe we're going to end this session here and continue in our next video. Have a wonderful time. Bye.